morning, and welcome to the latest edition of the National Security Space Association's SpaceTime interview series. We're glad to have you with us today. My name is Chris Williams, and I am honored to serve as chair of the Mormon Center for Space Studies, the association's in-house think tank. And I'm very ably assisted today by Matt McNitt from NSSA. Matt, thanks for all you do to keep the NSSA trains running on time. You're a great American and a great assistant. Thank you. I encourage those of you who have not had the privilege to know or work with General Tom Moorman, the namesake of our center, to look into his stellar career. Not only did he have a profound impact on the national security space enterprise, but he served as a role model and friend to many. He very patiently mentored me on key national security space programs and activities earlier in my career when I served on the House Armed Services Committee staff. General Moorman is sorely missed on both a personal and professional level. Today, we're pleased to welcome Dr. Derek Tournear, Director of the Space Development Agency within the U.S. Space Force. Derek, welcome back.
Thank you, Chris.
Before leading SDA, Dr. Tournear served as Assistant Director of Research and Development for Space within the Office of the Undersecretary of Defense for Research and Engineering, where he was responsible for coordinating all DoD efforts in space and initiating programs to address those critical gaps. He previously held leadership roles in industry, most recently as Director for Harris Corporation Space and Intelligence Research and Development. Prior to industry, he held program management positions at the Intelligence Advanced Research Projects Agency in the Office of the Director of National Intelligence and the Defense Advanced Research Projects Agency, or DARPA. He has a professional experience at Los Alamos National Laboratory, managing intelligence and defense programs. Dr. Tournear has a PhD in physics from Stanford University and a BS from Purdue University. Derek and his talented team at SDA are on the front lines of the vital efforts to ensure that effective and resilient U.S. national security space systems are on guard to protect and defend America's interests in an increasingly dangerous world. But don't just take my word for it. Here's what Defense Scoop said recently, and I quote, Derek Tournear is wrapping up an eventful year as the director of SDA. The agency successfully launched the first demonstration satellites for the proliferated warfighter space architecture, all while managing a fast-paced acquisition strategy for the constellation's future satellites. As leader of the Space Force's disruptor for space acquisition, Tournear has embraced a spiral development approach that calls on the agency to incrementally deliver new capabilities in multiple iterations, enabling the latest technology advancements and quick pivots in response to threats. And then a quote from you, Derek, is, unless we get on this model of spiral development and get new capabilities up there every 2 years by hook or crook, we'll never get ahead of the threat and be able to keep up. Derek, to you and the team, congratulations on the tremendous progress SDA has made in such a short period of time. And just here are a couple of the highlights from the organization's recent activities. You issued a solicitation for design, fabrication, and launch of up to 8 fire control on-orbit support to the warfighter program known as Foo Fighter, or F2. You've had a successful completion of space-to-ground transmission from Link 16 Tactical Data Network. You issued a request for future optical communications waveforms, gained approval to begin limited testing of data satellites, Link 16 nodes. You announced multiple awards to build 100 alpha variant satellites for Tranche 2 transport layer. You issued a solicitation for Tranche 2 tracking layer space vehicles. You're closely monitoring the on-orbit performance of recently launched Tranche 0 satellites. You issued awards to build 72 beta variant satellites for Tranche 2 transport layer, and you announced mission expansion at Grand Forks Air Force Base and much more. A real slow-moving organization, isn't it, Derek?
Today, my hope is
quite a year indeed. Today, my hope is that you can provide our listeners with both a look back at the progress over the past year and also a look ahead to some of your key objectives, program activities, and solicitations, other operations for 2024. As part of your presentation, if you could highlight some of those key solicitations that you see coming down the pike, that would be especially appreciated. So thanks again for being with us today, Derek. We look forward to your remarks. Without further ado, the floor is yours.
Well, thank you, Chris. Yeah, that was an excellent summary of a lot of the things that we've accomplished this past year, and I'll go through that. So just to level set what we're doing at the Space Development Agency, I want to make sure that everyone's aware of exactly the capabilities that we're focused on to be able to provide to the warfighter. So I have a slide that talks about what our main focus areas are. So we'll go ahead and go to the next slide, please. What we're concentrating on is primarily being able to support terrestrial warfights from space. And so we have two capabilities that we're promising to deliver. And the capabilities are very similar, but I'll go through them. Capability number one is beyond line of sight targeting for moving targets. Essentially, think about this as if you have a mobile missile launcher or you have a ship. I want to be able to detect that, track that, calculate a fire control solution, and then send that fire control solution down to a shooter and do all of that essentially in real time from space. That's the ultimate goal of our beyond line of sight capability. Second capability is very similar to that, but the targets are different. Instead of mobile missile launchers and ships, I want to go after hypersonic glide vehicles or advanced missiles while they're in flight. Detect them, track them, calculate a fire control solution, and then send that down directly to a shooter or an interceptor to be able to take out that threat. This is the ultimate goal, be able to do this and do this all in near real time from space. Now, what makes us different is we're building this architecture to provide these capabilities to the warfighter on two main pillars. Pillar number one is proliferation. We're not going to do this with a handful of very exquisite satellites. We're going to do this with hundreds and hundreds of satellites that are in a low Earth orbit. That's pretty profound in its own right. But now a lot of people are starting to accept that that is the future of space and space capabilities, is proliferation in low Earth orbit. Not only are we doing that, but the commercial industry, which we're tailing off of, is clearly starting to build up more and more proliferation in low Earth orbit. So that leads us to pillar number two, and this one is just as profound, and that is spiral development. In order to get those capabilities that I outlined as quickly as possible, I can't just say I'm going to go to that as my end goal and I'm going to put a line in the sand and I'm not going to deliver anything until I get to that end state. I'll never get there. If I do, I'll assume that I'll get there in 15 years. I certainly won't get a capability before that. So we do spiral development. We take those two, beyond line of sight and advanced missile targeting and tracking as our end state, what we want to complete, and we say, what is the state of the art that I could buy and field and have developed and on orbit in 2.5 years? What is that? And that's the next spiral that we go after. And we do that in a series of spirals or tranches. So if you go to the next slide, please, we'll talk about the timing of when we actually deliver those capabilities. So our spirals, we call them tranches. And right now we're in tranche 0, which are the satellites that we've launched in this year. Those are 28 total satellites that will provide a warfighter immersion tranche. What that means is it's not enough satellites to affect a fight, but it is enough satellites to where we can get the capabilities from space to the ground so that our warfighters can start to use those capabilities in exercises, so that when Tranche 1 gets launched, which is just about 9 months away, it's in September of 2024 is when we start launching Tranche 1. That's our initial warfighting capability. That will be up to 161 satellites that actually provide capabilities to affect a fight, and that will be operational. So Tranche 0, we'll demonstrate it, we'll exercise with it, we'll train with it. Tranche 1, we'll use that if we need to in a fight. Tranche 2, which then comes just 2 years after Tranche 1, every 2 years like clockwork, Tranche 2 will build off on Tranche 1 to proliferate it for more resilience and more global coverage, and then also add additional capabilities based on what is state of the art now. And I'll talk about more details on what's in Tranche 2. The beauty of the spiral development approach, though, is if you look at Tranche 3 and Tranche 4, I really don't know what's in Tranche 3 and Tranche 4. Tranche 3 will launch in September of 2028. It'll be hundreds of satellites. The specifics of those capabilities aren't yet defined, and they're not defined for two reasons. Number one, I don't know exactly what the state of the art of the technology will be in that time frame. And number two, the threats change. And so I want to make sure that we can adapt to that threat. So we'll snap the line on what the minimum viable product is for Tranche 3 in about a year. And at that point, then we'll start acquisition for Tranche 3. And then, of course, Tranche 4, we won't know until another couple of years. That's the whole beauty, because then I can adopt what commercial technology is available and fold that into the future tranches, as well as adapt to the current threats. So if you go to the next slide, it'll talk a little bit about what we actually demonstrated in this last year. As you highlighted, we had a lot of successes. A lot of what you talked about were our advantages and advancements in what we did for the solicitations, put on contract and such. But where the rubber meets the road, it is what have we actually built and launched? And this is when it became real. So in Tranche 0, Launch 1, We launched 10 satellites on that first launch. It actually went up in April, but I'm always going to say we launched it in March because we had it on the rocket. The rocket was ready to go in March, and then the check engine light came on the rocket, so that it took them a day to clear that, and then we went ahead and launched on April 2nd, because you can't launch on April 1st because it's April Fool's Day. But we launched those satellites, and if you look at this, so there were 10 satellites. If you look at the launch stack there in the middle, the two on top were SpaceX satellites providing the tracking mission, missile tracking. And those satellites have a Leidos payload on it to do the missile tracking mission. And then 8 satellites that are wrapped around those ESPA rings on the bottom were York satellites that provide our transport capability, data transport. So they have laser comm communication to form a mesh network, also laser to the ground, laser to airborne. And then they also have the Link 16 payloads, which allow us to communicate to the terrestrial user to existing fielded radios that our joint forces use, as well as our allies. And then we had that beautiful Falcon 9 launch that gave us a perfect launch. If you look at the next slide, talks about the second launch. So this launch, again, was ready to go, ready to fire in August. And then we had just a couple days delay. So it actually launched in September, but I'm going to count that as an August launch. And this was an additional 13 satellites that built out now there's a total of 4 SpaceX tracking satellites on orbit, 9 York transport satellites on orbit, and 10 Lockheed transport satellites on orbit. So all of the remainder of those were launched on that satellite that you see going through encapsulation in the center there. The only remaining satellites we have on Tranche 0 are 4 L3 Harris tracking satellites that will launch early in 2024, along with Missile Defense Agency's HBTSS program. We're going to fly those in the same orbit so they can tip and queue and work off of each other to demonstrate how we can go from a tracking system to a fire control system. So those 4 satellites are built and awaiting launch. And if we want to go ahead and go to the next slide, talk about the those 2 beautiful, perfect launches. They were return to pad launches out at Vandenberg. It was great to see. For the team that actually saw it. I went out to see the launch, and unfortunately, because of the couple-day delay, I had to come back and watch it with the rest of the world on YouTube. But it was great to see on YouTube. One of these days I'll actually see one of our launches in person. But that's okay. Not bitter about that at all. But keep in mind the time frame. So for those tracking satellites, those SpaceX satellites, order to orbit, 27 months. That's how long it was. That's how quick we were able to go from putting a vendor on contract to getting them into orbit. 27 months. For York's transport satellites, that was 30 months from order to orbit. So put that in perspective. That's extremely quick. The price point for the transport satellites was just at $15 million for each of that's across the entire averaged across both York and Lockheed for the transport satellites. So that's kind of the price point that we want to continue to hit going forward on our mainline transport satellites. Obviously, when we're doing new technology and stuff, there'll be a little bit more, but that's kind of the main price point we're targeting. If you look at that, that's when it became real. That first launch there on April 2nd, that's when SDA launched the initial instantiation of what will be the proliferated warfighter space architecture. We were no longer just doing paper. We were no longer just building satellites, but we're now operating satellites on orbit and demonstrating the capability that the warfighter will use in the future to give them this entire global JADC2 capability. So if you go ahead and go to the next slide, please. What we've demonstrated on orbit to date. So we've demonstrated that the tracking satellites, the SpaceX tracking satellites, are working well. We're able to get imagery down from them to be able to demonstrate that capability. And then as a first, we were able to demonstrate Link 16 from space to ground. And we actually demonstrated this over a Five Eyes partner. And we have permission to do this over that particular Five Eyes partner, as well as international space over international waters. We got the approval from NTIA around noon on Tuesday before Thanksgiving. And that night, between 9 and 10 o'clock, this is all Eastern time, 9 and 10 o'clock Eastern, that same night, we were able to demonstrate that. So that just showed how ready to go our team was on the ground, primarily not only the SDA team, but we had NRL and we had the Eglin team, the 46th Test Wing Test Squadron working from, they moved from Eglin Air Force Base out to that Five Eyes partner to help us with this test. So kudos to them. We were able to do that test and everything worked perfectly during that first test. Why is this so important? Link 16 is a tactical radio that we use to communicate line of sight. So think 200 to 300 nautical mile type range. Right now, that's what we'll use in a fight. That's what our joint forces all have on their dismounted units. They have those on ground vehicles. They have them on air vehicles. They have that on ships. Link 16 is ubiquitous. Also, our allies use Link 16, and it's been around a long time, and we've all been training with it. We know how to use it to affect a fight. We use it for command and control. We use it for passing targeting data, etc. But if we're going to go against a near peer adversary, we're going to have standoff distances, and we're going to have an area of conflict that extends beyond that 200 to 300 nautical mile range. In order to make the JADC2 vision, which is take any and all available sensor data and get it to any and all available shooters as quickly as possible. In order to do that, you have to have a tactical data link that works essentially globally. It works beyond line of sight. Now, it is too slow and too costly to force all of the services to upgrade all of their radios that they have on the ground when you're talking about hundreds and thousands of user equipment. So what we demonstrated was that we can go down to unmodified Link 16 equipment on the ground from space, so that we just turned those fielded line of sight terminals into beyond line of sight capability that now the joint warfighter can use to affect a fight over a very large region of interest. And so that's why this is a big deal. And that's why we were so proud and so happy to see this demonstration progress. All right, now go ahead and go to the next slide, please. This is a quick snapshot of everything that we accomplished in 2023. So if you start at the top and then you work your way down, there's a few key points I want to point out there. So that March/April is when we had our first Tranche 0 launch, so the first launch of the PWSA. March is also when we received the Warfighter Council concurrence on our Tranche 2 transport layer minimum viable product. That is the basis we use for requirements validation. As I mentioned, we have that ultimate goal of that beyond line of sight capability and that global missile warning, missile tracking, fire control. And that's essentially accepted by the Joint Staff and the JROC. But for each of the intermediate spirals in our tranches, each of those goals and each of those requirements is set by a minimum viable capability line that gets approved by the Warfighter Council. And that Warfighter Council is primarily made up of general officers and SES, or senior executives in the Department of Defense, representing the combatant commanders and the services. And it is chaired by myself and the Vice Chief of Space Operations, and we set those goals. So that happened in March. Same time frame that we're launching satellites, and then we went ahead and a month later, then we put out the solicitation. We put out the solicitation almost immediately for Tranche 2 transport layer, and then you can see then we started to in August. That's when we were done with source selection, put those on contract. We average right around 100 days from solicitation to award, and that's a metric we track very closely to make sure that we continue to keep that rapidity. There's that in August, we had that test and checkout center addition announced, as was previously mentioned. Chris mentioned that at Grand Forks Air Force Base, and that shows an artifact of the spiral development approach. So the reason that test and checkout center was needed was as we go from Tranche 1, which will be flying and operated out of Grand Forks Air Force Base and Redstone Arsenal, we need to be able to have a capability to bring Tranche 2 through launch and early operations, tests and checkout before it's operationally accepted and it can move on to the ops center floor. We didn't really have a center to do that. We didn't have an ops floor to do that. And so in the spiral development approach, we recognized that was something that we needed to add. We were able to move quickly. And that's what we did in August, was we moved that quickly to start construction on that test and checkout center so that we added that capability to be able to field new tranches. And then as we went through the year, in September, you'll see there, that's when we had our second launch to launch those remaining Tranche 0 satellites that are on orbit. And then early next year, you'll see all of the Tranche 0 satellites on orbit with the last 4. And so it's a pretty exciting year when you look back at everything we've accomplished, and we'll continue to push. We're not going to slow down in 2024. So go ahead and go to the next slide. So this is just showing the importance of what our success has done within the Department of Defense and the entire industrial base. If you look at the left, on the left side of this chart is what folks within the Department of Defense, and these were senior DoD officials that were what they were saying about the Space Development Agency in 2019. Essentially, if you think about what those two pillars I mentioned, proliferation of hundreds of satellites in low Earth orbit, you can see that was not accepted there. Quotes, launching hundreds of cheap satellites into theater will result in failure on America's worst day. The whole concept of needing a new acquisition agency that's going after this spiral development approach was not accepted. It was called a pet project by the acting SecDef and the Undersecretary of Defense. It just was not something that was accepted. But now, if you look at quotes from 2022 and on, and this is because we've been so successful, now we're actually part of the mainstream. So when we are called the disruptor, and always like to put in there constructive disruptor, that's actually a term that was added by my friend in the Air Force, Mr. Sean Barnes. And that is important because we are not trying to break anything necessarily that the department is doing. We are trying to build off of all of the capabilities and add to it in a constructive way, disrupt the current processes, but do it constructively. And you can see that that's been accepted. So if you look at the quotes now, you can tell that the concept of proliferation in LEO is accepted as the way we're going to continue to do business. The concept of moving incredibly quickly on these 2-year cycles is accepted as the way we're going to keep moving forward. In fact, Assistant Secretary of the Air Force, Frank Calvelli, one of my bosses, I have two bosses, he's one, and then the Chief of Space Operations, General Saltzman, is my other. They're fully bought in. Frank Calvelli has put out 9 tenets of space acquisition, and essentially they codify what we're doing at SDA. We need to go smaller systems, faster systems, fixed price, keep the ground at pace with space, and those kind of things. So you can tell we are now part of the mainstream. Go ahead and go to the next slide, please. This is what we're planning on launching starting in 9 months from now. So Tranche 1, 161 satellites total if you add up the 3 on top, with 12 demonstration satellites that are not actually part of Tranche 1, but they launch about the same time. We have demonstration satellites that are timed with our tranches to burn down technical risk for the next tranche. But we will have 126 satellites that perform the Link 16 mission. That will give us full global persistence of those tactical data links. We'll have 35 satellites that are performing the tracking mission, missile warning, missile tracking. That'll give us global coverage. Pretty much, we'll have a couple areas that have holes that move around the globe in Tranche 1 that will get filled out later. And then additionally, 4 satellites that will demonstrate the fire control. Those are building off the technology that MDA has developed for their HBTSS. So those are fire control systems. So that's what makes up the 161 Tranche 1 satellites that begin launching. That is an 11 launch campaign over 11 months, 1 launch a month, starting next September. So that's all pushing forward. And the ground will be at Redstone Arsenal and Grand Forks Air Force Base. And our ground integrator is General Dynamics, with a major partner of Iridium. Go ahead and go to the next slide, and we'll talk about what we're now putting on contract for Tranche 2. So we have a tranche that is in operation. That's our demo tranche, Tranche 0, warfighter immersion. Tranche 1 is in build now, right? They're in assembly, integration, and test, getting ready to launch. And then we have Tranche 2, which is in acquisition, where we're just finishing up the review phases and getting started on awarding contracts, so that then we can start into the build phase, and that'll happen about the time that Tranche 1 is launching. So if you look here, we've from left to right, we've awarded 100 satellites total, 62 to York Space Systems and 38 to Northrop Grumman, and that is to fully build out our Link 16 capability to make it more resilient, so that we have some resiliency just due to proliferation in that constellation. The beta satellites we have, if you look at the numbers there, it says 90 satellites and 6 planes. But if you're tracking us closely, you'll recognize that we only have 72 satellites on contract right now between Northrop Grumman and Lockheed Martin. And so I will tell you that we are looking at putting another approximately 18 satellites on contract, and we're working with a third vendor to do that. And we should make that announcement shortly. But that's beta, and that is our TAC SATCOM mission, which is UHF and S-band, and it that will proliferate and make operational a capability that is being demonstrated on our TIDES, or our Tranche 1 developmental and experimentation satellites. Tranche 2, Gamma, is flying the Warlock mission. So that's about 20 satellites. The draft solicitation for that went out just a few days ago. That's a classified mission. And then you get into our tracking systems. So we have 48 tracking satellites with 6 that do fire control for 54 total. And those are in source selection now. And we plan on making the announcement of those awards imminently. So go ahead and go to the next slide, please. That's, this is just a one-page summary for your reference to see what has been planned, what's been awarded, and how we're moving forward. You can go ahead and go to the next slide. This is if you look at the PWSA, our entire architecture, over out until 2033, 2034. Just the concept of this is mind-boggling to see how many satellites, how many acquisitions, and how many launches we will have going on. If you look at the top, each one of those triangles is a launch. Each one of those triangles is a rocket that's going into space carrying a dozen or so satellites on it to proliferate this constellation. And so you see that up there, the Tranche 1, those 11 launches back to back to back. It's pretty impressive, and that's pretty terrifying actually about how quick all this is coming together. Then if you look at the bottom is the cumulative number of satellites we will have on orbit. And you'll see those oscillations out in the outer years. That's because these satellites have a 5-year design life. And we've launched the tranches every 2 years. So every 2.5 tranches, we completely refresh the constellation. We have about 400 transport satellites on orbit at any given time when we're in steady state, and about 100 tracking satellites. That's what we oscillate around. It takes 80 satellites to give you 2 satellite coverage globally for a single mission. So that means we can support essentially 5 different transport missions with those 400 satellites, just 5 times 80. So those are 5 different distinct communication missions that we can support concurrently with that number of 400. And then in tracking, again, you have 80 satellites to give you the 2 satellite coverage globally for the tracking mission. You add resiliency on top of that, so you're up to about 100 satellites to be able to give you the full missile warning, missile tracking, fire control in perpetuity. Go ahead and go to the next slide, please. So that's where I want to close with, just to remind everyone, Semper Citius is our motto. And that is Latin for always faster. And that's what guides us every day. We continue to push to make sure we get these capabilities to the warfighter as rapidly as possible. We had a great 2023. We delivered a lot of capabilities, demonstrated a lot of things, continue to push forward, and we're not going to slow down in 2024. That's when we're going to launch Tranche 1, and we're going to continue to build out Tranche 2. So I'm excited, and it's a great time to be in space.
Well, thanks very much for those insightful remarks, Derek. Tremendous accomplishments for the team and for the nation, frankly. So well done to you and the team. Let's now turn to some question and answers, and I'll remind our audience that we very much welcome your questions for Derek today. And you can click on the Q&A button at the bottom of your screen. A few questions have already come in. I'll try to get to as many of those questions as possible in the remaining time here. We have about a half an hour left, so we should be able to cover a good number of questions. Derek, before we went live here, you and I discussed briefly the issue of some of your previous plans and mission areas, if you will. For example, the deterrence layer. And could you talk a little bit about how the scope of SDA has sort of refined and concentrated in areas, and what happened to some of the ambitions, some of the programs, activities, studies that were done in other areas, such as, for example, the deterrence layer?
Sure, certainly. So a friend of mine, actually, the president of Auburn University, has a quote, and he says, "Focus is a superpower." And that's what we use. We have that on our whiteboard here at SDA. And that's what we had to do to make sure that we could go fast and deliver the capabilities. We had to look at where there really were gaps and what was being missed. And most of those gaps at that time were terrestrial support to the warfighter, from space, getting those capabilities to support the joint fight on the ground. The Space Force at that time, it was still part of the Air Force, but the Space Force was shaping up. they really were focused and had a lot of activity to be able to control the space control or the fight in space. And so we viewed that as kind of covered. Space RCO and others were set up and doing a good job in that aspect. So we said we're gonna focus, and we're gonna focus on those two capabilities: beyond line of sight targeting for time sensitive targets, and then targeting and tracking of advanced missile threats. And so from that, the deterrence layer, which was really focused on the space fight with advanced maneuvering vehicles and things like that, we just stopped all work in that area and just focused on the terrestrial fight.
And given the experience that you've had to date within that narrowed focus on beyond line of sight and hypersonics, is there any reason to believe that the same processes, the same technological acceleration advancements couldn't be applied to the deterrence layer, to space control capabilities? It strikes me that there's an enormous opportunity here, and you and I lived through earlier debates over brilliant pebbles and things like that, and arguments as to how mature the capabilities were to do space defense missions. What's your general take on the technological readiness, maturity for being able to perform those kinds of missions, even if you're not focusing on it in a significant way under SDA today?
Yeah, I don't want to talk too much about the technology aspects, because there's a lot of technology development being done for these different things across different aspects of the department. But I will talk about how the model could be utilized for that. And I think that the spiral development model, certainly can be used for deterrence type missions. In fact, I think the model can be used for almost all DoD acquisition activities. There are always going to be very large bespoke programs that you need, right? I think it would be very difficult to use our 2-year spiral development model to develop a new aircraft carrier or something like that. But most other capabilities, I think you can use that model to get the minimum viable product to continue to push that forward. And the beauty of SDA, as long as we continue to demonstrate this success, more and more folks within the department will look to us as a model that works, and they'll start to use that in some of their other systems. The Army's actually using that now in some of their terrestrial radio and communication systems. So they're following the same kind of agile acquisition approach. And if you look at SSC, they're actually adopting it as well. So we're teamed very closely with them on the tracking layer. So we're doing a tracking layer at LEO. They're doing a tracking layer at MEO. The whole reason between the two is so that we have resilience, so that you would actually have to knock out a lot of satellites in both orbits to be able to get an exploitable hole. But if you look at the way SSC has set up their program, their track custody program at MEO, it's following this spiral approach. So they have spirals. They call them epochs instead of tranches, which is nice, because then you can say tranche and you're talking about LEO, epoch, you're talking about MEO, and they're in 2-year spirals, and they're continuing to adopt this. So it is a model that a lot of people are starting to integrate into their acquisition mindset.
That's helpful. Thank you. As you noted, and your slides depicted, SDA's issued contracts to a wide range of companies. Initially, there seemed to be an expectation that traditional large aerospace and defense companies wouldn't be sufficiently agile enough to effectively compete for these contracts, and that only small commercial space startups would garner most SDA contracts. According to the very talented reporter Sandy Irwin of Space News, her tally is that SDA has contracted with York for 62 satellites, Northrop Grumman for 56, Lockheed Martin for 52, L3 Harris for 20, Ball Aerospace for 10, and RTX for 7. Does that mix surprise you? I mean, did you anticipate that it would be primarily the vast bulk of SDA satellites would be from sort of the traditional aerospace and defense companies, or what's your take on that?
Yeah, it is a little surprising, but I'll tell you how it works out, and it's kind of interesting when you actually pull the thread on that. And in fact, those numbers from Sandra are quite a bit outdated now. If you look at the chart on what we put on contract now, we've got Northrop and York both have triple digits in their in their orders from us. But I'll give you a kind of a story here on how we looked at this. In fact, when we put Tranche 0 transport on contract, we looked at those solicitations that came in, and we went with best of breed based on our criteria, which was schedule first, then close second, followed by cost, and then technical. That's our whole goal to make sure that we can hit our price points and our schedules. And at that time, we awarded those transport satellites to York and Lockheed Martin. And York was at that time was a newcomer. I mean, they still are a newcomer. They're performing exceptionally well for us, but at that time they were really unknown. So it was really high risk to award those contracts to them. And then we had Lockheed Martin. And I said at the time, I said, man, this is really odd. So we're going to award to York, which has at that time, has a really high probability of failure. And then we're going to be relying all on Lockheed. And we are the agency that is the constructive disruptor, supposed to be doing things completely differently. And we're awarding to the F-35 vendor. But I'll tell you, it's worked out really well for us. So on Tranche 0, one thing of note, if you look at Launch 1, what do you notice about Launch 1? Who were the two satellite vendors that were on Launch 1? The new space companies, SpaceX and York Space System, and then Lockheed came in and was ready for Launch 2. Now there was not saying that there was a race or anything on there, but it is notable that they were on that first launch. They've also performed well for us. They're doing well on Tranche 1, so I have a lot more confidence in a lot of these new space companies and Lockheed. So one of the things that we had the fear of is that Lockheed, Northrop, Boeing, these big classical aerospace and defense companies would operate under their big classical aerospace and defense mentality on these programs. We've actually seen the opposite. So if you look at Lockheed, Lockheed's not doing the satellite bus for their satellites for SDA. They're buying those and they're partnered, but they're essentially buying those from Tournear Orbital, which is a new space company, which is based on a commercial model that's trying to sell those buses as a commodity product to commercial vendors. So they've really capitalized on that. In Tranche 1, Northrop came in, and got a lot of awards for us on Tranche 1. They're not building that bus. They're buying that bus from Airbus using their OneWeb satellite line down in Florida. So essentially buying that new space commercial bus, and they're using that to integrate. And what we're seeing is that the bigs, what we have Lockheed and Northrop on contract for a lot of our satellites, they are not acting like they do on these large cost plus contracts. We've got them on fixed price contracts. They're relying a lot on their new space partners to be able to provide the speed and the efficiency so that they can hit our price points and hit our speed. So I think that the mix may look a little, it may be a little misleading, because you have to pull the thread on who are their tier 2 and tier 3 providers. And it turns out that there are a lot of the new space, new companies that are in there. They just have a Lockheed or a Northrop wrapper on top of it. Loft Orbital is a major sub under those. I believe there's 12 satellites on for Ball there, and but those under Ball for that. So that's what I would say. Not only have we expanded the market base, but I think we've also changed the way the bigs do business. And so now they're starting to emulate more of the smaller companies as they team with them, and they're able to be almost as agile as you would expect from a true just new space company.
That's helpful. Thank you. Multiple defense contractors have made statements recently that they prefer to turn away from fixed price development contracts. Are you seeing any effects of this change on contractors bidding for work with SDA, and which is predominantly, as you noted, been focused on fixed price contracts? Do you have strategies for addressing this change across the defense industry, or what's your general take on that, and how you intend, or the agency intends to approach that? Every
time I see a press release on that, I get on the phone and call that company and ask them, hey, what does this mean for your work with SDA? Because we are intending to continue to use fixed price contracts, and that's the way it works. And every single one of them has always told me, no. That is not directed at SDA work at all. We're happy with our SDA fixed price work. That's directed at, and then they'll go into other contracts where they typically there's been a lot of large contracts out there that have had fixed price development cleanse on them, and then on that same contract have had very large procurement cleanse associated with it. And so that's a very high risk for the performer. Whereas if you look at the way our contracts are set up, we have we expect this order to orbit on the order of 30 months. So there's not a lot of really tough tech development because you just can't get that done and launch in 30 months. So they, the performers, industrial base is what they're telling me, right? And what I'm hearing. People on the line chime in if this is not the case, but you can feel more confident. You control your supply chain over that 30 months. You control what you're going to develop over that 30 months, and you can plan a program over 30 months that you can plan a certain amount of profit into, right? If you're trying to do that same thing over a fixed price contract that has a 10-year period of performance, for example, that's much more difficult and much riskier. And so I would say, when you see those in the press, that is not aimed at the way SDA is doing fixed price contracts, which have these, less than 3 years order to orbit.
Thank you. One question from the audience is as follows. Alternative P&T is a critical topic, as is protected communications, but unlike for missile warning or data transport, these require designs that include both user equipment and space systems. Will user equipment eventually become part of SDA's missions? Will you be producing user equipment in the future? And if not, how do you address those issues?
So I'll take that in two steps. First, I'll talk about our plans for alt P&T, and we have the same model where we want to be able to go down to existing fielded user equipment, because that's the fastest way to get the capability out there, right? It's a lot easier, a lot faster for us to build and launch satellites than it is to field thousands of user terminals. So we're working very closely with the Army, who's been pioneering the alt P&T across the Department of Defense. And their signal is, they have a signal that they broadcast out, alt P&T, that can be picked up with the next generation being fielded now and to be fielded GPS chips, the MGUI increment 2, right? The M code GPS user equipment increment 2. And we're working with them to be able to broadcast that same signal, so it can be picked up by existing fielded and planned user equipment. So there'll be no modifications. In addition to that, that's a little ways in the future. So that's starting in Tranche 2 and Tranche 3. We'll be fielding more of that. Starting in Tranche 1 and then continuing in Tranche 2, we are putting a navigation message into Link 16. So Link 16 has been around since the 80s, right? Before GPS was used in combat. Link 16 is what we were going to use for our navigation and timing during that time before GPS. It still has that capability. You can embed a navigation and timing signal into Link 16, and you can use it for that. It's not nearly as good as GPS, but it does give you an alternate. And we calculate our own position, navigation, and timing on board our satellites independent of GPS, just by doing timing transfer between the satellites. So those are examples of how we're going to provide alt P&T without any changes to the user equipment. Now, we are investigating future plans for broadcasting an alt P&T signal, either over L-band or over S-band, that would require new user equipment. And for that, we would not buy that and field that. We're working with the services to make sure that they are in lockstep with us, so that they would field such terminals in their equipment, either before or right after we would field a space capability. So we're working with them, and that would be a Tranche 3, Tranche 4. That's why I said we haven't snapped the line on that. Now, for some of the user equipment, KA in particular, KA user terminals, those we are looking at putting out there for certain user communities, user terminals that we would fund and give to them as early adopters, so they could use our KA communications backbone to tie into our transport layer. And that is when we would provide terminals to them, but we would do that on a early adopter, kind of low rate initial production capability for fielding the thousands to hundreds of thousands that would be needed for the entire service. We would have the services do that, and we just make sure we're synced up with them.
Thank you. We have another question from the audience that asks, do you expect that middle tier of acquisition pathway, specifically rapid prototyping, to continue to be the most appropriate acquisition mechanism or process for delivering on the SDA tranches? I
do. So in fact, the Defense Business Board just published a report that had several recommendations to maintain speed of acquisition so that we can do things better within the department. And one of their, they had a couple different recommendations in this area. One was utilize middle tier of acquisition, utilize OTAs, move the middle tier of acquisition approval authority from right now it's at ANS level, move that back down into the SAE. So at that point, that would be moving the space middle tier of acquisition approval down into Secretary Calvelli's purview. All of those would enable more middle tier of acquisition utility. So why do I think it's good? So it's good because if you use you either have the major capability acquisition, MCA, or an MTA. If you do major capability acquisition, there is typically a lot of reporting that goes along with that. And that adds very little value to a program that is delivering in 2 to 3 years, right? Because those are typically reports that are expected if you have a program that's going to deliver over 10 years. So it's just the entire process for major capability acquisition is designed around how you maintain oversight on a 10-year development program. We're not in that model. We're in the model of we're going to deliver and field a capability in 30 months, and we're going to have new spirals that launch every 2 years. And because of that, you have to get into this completely different acquisition mindset. If you look at the way major capability acquisition was designed, it was designed around a time when you had very stovepipe systems that weren't all tied together. They had their own development activity, then their own fielding or procurement activity, and then their own operations and sustainment before they started a new development that would be a completely new program. We're not in that method. We're more along the software acquisition pathway. So we actually build these things in spirals, and the entire overarching architecture is the PWSA, our Proliferated Warfighter Space Architecture. Very similar to if you look at the Missile Defense Agency. Missile Defense Agency has their ballistic missile defense overarching architecture. That is their main program. And within that, they have various spirals. And so they use this kind of agile approach as well with hardware, just like one would do traditionally with software. So that's the approach that we're going to continue to push. It'll allow us to go more quickly and can keep up the speed and keep the major capability acquisition for the longer 10 to 15-year development programs.
Thank you very much. I have a couple of questions on threats and space mission assurance. Obviously, adversary threats continue to advance and range from direct descent ASATs, jammers, directed energy, lasers, EMP weapons, railguns, satellites with grappling arms, cyber attacks, and much more. Which of these adversary counterspace systems worry you the most and why? And what is SDA doing to be able to counter these and other threats? And then a related question on mission assurance. Space mission assurance includes a broad range of measures such as defensive operations, reconstitution, disaggregation, distribution, resilience, diversification, active and passive protection, proliferation, and deception. Which of these features are being incorporated into SDA systems and architectures? And should SDA rely mostly or even exclusively on proliferation to achieve resilience, or are there other factors, other capabilities that are being added to the mix that help build a more robust and resilient architecture?
So our primary method for resiliency and for robustness is proliferation. So we proliferate, and that has the forcing function on proliferation is that you have to be affordable. We do actually put some protection methods on some of our satellites, but we have to do that in a way that's affordable, right? We don't want to double the price of the satellite or even add 20% price to the price of the satellite to add features that we feel the better way to fight that battle is just through proliferation. So we just want hundreds and hundreds of satellites. So if you look at that and you say, okay, that's how you're going to get resilience is through proliferation, it takes most of those weapons off the table. Direct descent ASAT, a lot of those threats are just too expensive if you've got a 1v1 type scenario. So that's not going to help the adversary. It's just too difficult a value proposition for them to attack you that way. We're at 1,000 kilometers, so we're quite a distance for a lot of the ground-based directed energy threats. So that's a big advantage there. So the only real threats I'm worried about are the common mode failures. And the two common mode failures that I'm most concerned are number one, cyber, and then number two, supply chain. And that's supply chain interdiction to make sure that there's nothing that's happened nefarious been entered into our supply chain, as well as just making sure that the supply chain is healthy enough to maintain the production capability. So we have a lot of measures in place for cyber protection. We take it very seriously. In fact, we red team all of our software design from our spacecraft and our ground vendors through the National Cyber Range to make sure that they can try to hack it, see if they can find any vulnerabilities so that we can correct that. Our model for what we put into our contracts for software assurance and the way we handle software assurance within SDA development is being used as a model across the Space Force because we've been taking it so seriously. Our CIO at SDA is a former, offensive cyber individual researcher from DARPA. So, that's the way he views the world, is how I can attack and take these things out. So we take it very seriously because that's common mode failures are the ones we worry about. We also get an advantage. We will compete and we will select vendors with different designs for each tranche and each layer, each capability layer. And that means that we'll have a homogeneous system, a heterogeneous system that has different designs, so that if one design does actually have a software fault, it likely won't be common mode across the entire proliferated system. So we also have that in place. Now, for supply chain interdiction, we have the same kind of things put in. We have non-destructive testing along the lines where we have unwarned random testing and screening of parts. We also have some procedures in place that the vendors need to go through to vet their supply chain, because those are the two areas that concern me the most.
A question from the audience is, what is the current state of the dispute with the FAA over allowing Link 16 testing in U.S. airspace? And also, will SDA test more advanced data link methods in the near future?
So our friends at the FAA are, their primary concern is to make sure that there is absolutely zero possibility of any kind of risk for commercial air traffic. Okay, understand that. So because of that, they have some very specific requirements, because Link 16 shares some bands with some of the navigation some of the navigation aids that are used for commercial aircraft. So FAA and the DoD have come to agreements on what the DoD needs to demonstrate to be able to operate Link 16 over the national airspace. And FAA has been accommodating and helping us come up with those agreements. So with that, the DoD now has to go through a certification process on any new radio. And that's where there's a little bit of rub, but we're working through that. Any new radio means any small change, even if it's a software change on the radio, go through this certification process, which the Navy owns, validate that. And then the FAA says, once that gets done, then they'll give us approval very rapidly to do testing over the national airspace. The DoD side, we have not completed that testing for our radios on orbit yet. We're in the process of doing that, and we expect to get those tests completed very quickly. And then FAA will allow us to have a temporary frequency authorization over the national airspace. As it stands now, we can't operate over the NAS, but we do have approval to operate one variant of our radios. So we have the York satellites on orbit. We also have the Lockheed satellites on orbit. Those are flying different radios. So we have approval for the York satellites to operate those over this Five Eye partner and over international water, but we have not yet got approval for, and this is through NTIA, approval for the radio that's on the Lockheed satellites. So we're working that process as we speak. But that's kind of where we stand, to make sure we get all the tests done so the DoD can check the boxes that they're certified, and then FAA can give us approval in the national airspace. For advanced tactical data links and next generation tactical data links, yes, so that is what we're demonstrating in our TAC-SATCOM program. So that's part of TIDES, and it's also our T2 beta is some new tactical data links. And then as part of TUDES, which is our Tranche 2 developmental and experimentation satellites, we want to test out a wide range of new tactical data links, because there's a lot of tactical data links that are used. Link 16 is the one that's most prolific, but there's a lot of different tactical data links, and we want to be able to talk to as many of those as possible. And so that's kind of the point of TUDS, to demonstrate that we can do that.
We have another audience question, very interesting question. It says, do you see commercial imagery acquired by the NRO plugging into the SDA architecture to support targeting or BDA? And I guess it raises a broader question of how SDA data that's derived from SDA satellites or comms from SDA satellites, how does that in a practical sense get plugged into combatant command architectures, networks, and get to the pointy end of the spear?
Sure. So I'll work the second part of that question because it's easier, and then I'll talk about that first one, which is a little messy, but I'll talk about all the aspects we're doing with it. So the second part is how do we get the data from the transport layer to the pointy end of the spear? So the whole vision of JADC2, right, is to connect all of those data to all of those shooters. And we do that primarily through the services instantiation of their JADC2 nodes. So for the Army, that's their Titan nodes. That is what will be in theater, essentially at the battalion level, doing command and control, targeting, and that's that forward end of the spear, being able to take those data. So we'll talk to that through the transport layer via optical and KA. The Navy equivalent is MTC. So we're going to talk to their ops centers, which is their JADC2 forward operating node. They'll have those on ships. So that's how we'll get the data to the end shooter. On the Air Force side, it's a TOC, targeting ops cell. Same thing. It's very similar to, in fact, a lot of the hardware is very similar to what's being used for the Navy and the Army. Be able to talk to that. That's how we move data from the transport layer to the pointy end of the spear when we're not going down link 16, right? Link 16 is when you're moving it, directly into the fight, because you get it to the ops centers and they can use that to make decisions and push that data out. And then if they want to push that data directly to an F-16, F-18, F-35, whatever, then they can use our transport layer to push that via link 16. So that's how you really can close the kill chain. Now, the first part of that question is, okay, how do we get data, ISR type data, either commercially or from our other government partners? How do we get that onto the transport layer so that it can be fused, and can we? That's our ideal case. What we're looking at is we've got contracts with a couple different vendors now, so that we can work through all the machinations to get commercial data onto the transport layer. Now, physically, that's pretty easy to do. We have a published networking standard. We have a published optical standard. So anyone can build to that standard and they can plug into our transport layer from a physics and from a hardware interface layer. So we're doing that. We're testing that out with folks. Where it becomes a little more difficult is for that authority to connect. So our system is operating at a secret level that's touching a lot of other secret levels. So we can't just let anybody willy-nilly connect into the transport layer just because they happen to be able to plug in. We have to have an approval process where we can give strict authority to connect in order to do that. And so that's one of the things we're going to demonstrate on TIDES, on NEXT, and on TUDES, so that we can work with other commercial vendors as well as other mission partners, so that we can work through how that would all work and do those handshakes to be able to make that happen. Right now, we could pass the data across just fully encrypted, but we would not be, so we could pass data encrypted from a mission partner, say, to a Titan, an MTC, or a TOC. They could decrypt it and use it. So that's one way to do it. But if we wanted to actually fuse the data on board, that's when we have to have this authority to connect. So we could fuse the data on board and then move fused data to link 16 or something like that.
Thank you. We have a question from the chair of the board of NSSA, Joe Dodd. Joe asks, to what extent do you see international cooperation becoming more integral to your technology and acquisition planning? Do you see opportunities for cost sharing or even joint programs with friends and allies?
So one of the things we've been very open with is to make sure that anyone that wants to and is an ally can plug into our system, and we can help them move data, and we can ingest their data, and we can move that to whomever. That's why link 16 is so important. Link 16 is used by all of our allies. So they'll be able to plug into our network. The networks themselves are controlled by the individual combatant commanders. They set up the network, and we'll just be plugged into that network as if we were just some other some other aircraft on that network, and that network will have allied as well as just joint force folks plugged into it. So that's one way to do it. The other way to do it, obviously, is we have ground stations across the globe. We're working with our allies to host a lot of our ground sites for our ground entry points. So they're hosting us so that we can use their locations on the ground to be able to get data up and down. As far as in-space connectivity, that's something we've investigated with several different allies, where I don't want to set up a joint program where, we jointly fund something and we deliver it. But what would be good is if an ally wanted to field a missile tracking capability, for example, that was in an orbit that gave a lot of concentration over their particular area of responsibility, they could do that. We would work with them so that they could plug their data directly into our transport layer. We could fuse that with our missile tracking data and send that down and disseminate it to whomever was on that network and wanted to get it. So we're working with allies to share data that way.
That's great. We have time, I think, for just one or two more questions. Can you talk a little bit about how important high-speed optical communications are to the effectiveness of the PWSA? And where is how you would characterize the technical maturity of some of those capabilities and systems, and where you see it going, additional investments that are needed? There's other organizations in DoD. DARPA has Space Bacon, probably the most ill-begotten acronym you can come up with, but other programs along those lines that may contribute or may not contribute to what you're trying to do. Can you talk a little bit about optical communications?
Sure. So it is integral to everything we're doing, right? We want this mesh network, and the best way to get that mesh network working is with optical crosslinks, so that you can get the high bandwidth. It also helps a lot with spectrum management. That becomes more and more complicated the more satellites you get up there and to try to deconflict different spectrum issues. Laser crosslinks help with that. Laser to airborne systems, laser to ground, much easier to do spectrum deconfliction. So we do that. We rely on that. That's incredibly important to us. As far as the technical readiness and such, so we require essentially everything to be at a technical readiness level 7 or better before it's added in as part of our system. But more fundamental than that, since we published our optical comm standards, there are now many companies out there, both in the US and internationally, that have as part of their catalog commercial parts now that they say right on there, SDA optical comm terminal compliant, right? Optical standard compliant. So you can buy them. You can just they're not on Amazon yet, but I think they will be soon. But they're commoditized components, and so the maturity level is there. Now it's just a matter of making sure that all of those companies can ramp up production, because we're buying hundreds of these terminals, right? So that exists. In addition to that, to make sure that they'll work, we have at the Naval Research Laboratory, they've built an optical interoperability test bed that is incredibly important. Because if I have a terminal from vendor A and a terminal from vendor B, and they both say that we meet the OCT standard, how do I test that before I tell them, okay, we're going to buy hundreds of these? Take them to NRL. NRL has the gold standard that we use as our test bed, and they can talk to that and demonstrate that it works. And then we can also have vendor A and vendor B talk to one another to make sure that they can communicate. They can do pointing, acquisition, and tracking. All of that can be tested out. And once that interoperability is verified, we check the box, and essentially then you get the checkbox that you are compliant, and you can move forward to production. Now, Space Bacon and others, that's obviously you never want to put a DARPA program on your critical path, but you always want to watch it, because if it becomes real, to see what an impact would be. There are a lot of optical comm standards out there, right? Ours is specifically optimized to be low size, weight, and power and cost, so that we can proliferate thousands of these things eventually. And in addition, we want to make it easy to go from space to the ground without advanced optical processing on the ground. So that kind of is what defines our optical comm terminals. There's a lot of other optical crosslinks that don't have those constraints. Either they don't care about the size, weight, and power and cost as much, or they don't care about going to the ground. So they'll be optimized differently. So the standards can't talk to one another. Space Bacon is beautiful for that, because Space Bacon then would be an easy way, so you didn't have to have multiple comm terminals on a satellite to do our translator sat is what we term it. That's a satellite that can translate from one standard to another. You just have Space Bacon, and it does the translation on one single optical head.
And last question is turning to the Congress. How does having to operate under a continuing resolution impact the work of the Space Development Agency? What are the constraints that it imposes, and how badly does it bite and delay and impact your programs?
So it is actually an extremely big deal. So if you look at where we are, right, we've got satellites on orbit operating. Tranche 1's about to launch 161 satellites coming up here. Those we'll continue to push forward with, but we're hot and heavy into acquisition of Tranche 2. We have solicitations on the street. If you mentioned Foo Fighter and then the draft for the transport layer Gamma, those are on hold. We most likely will not award those until we get out of a CR, just because there's too much uncertainty in what the budget will hold. So that will be a delay if the CR goes on beyond that. If the CR even goes further and we do get into this mandatory FY23 -1% cut sequestration, that essentially equates to about a 14% cut in the Space Force budget from the budget request to what would be enacted under that sequestration law. That's a big deal. Now we're talking about we may actually have to terminate or stop work on existing programs. TUDS would likely not be able to go forward, and again, Gamma and Foo Fighter would be some of the first to go. Now that's from clearly the impacts to SDA and what we're tracking very carefully. It's a big deal. It's real. It's not something that's easily mitigatable. But from the department, and especially the Department of the Air Force at large, if you look at it, the whole point is there's no way that we can effectively compete and continue to outcompete our near peers with our hands tied in this way, where we have to operate in an uncertainty over 3, 4, 6, or an entire year-long CR. It's just too much uncertainty. And so that is the biggest thing that we could ask for is predictability in the budget, with passing a budget so that we can continue to move fast. Because right now we can move as fast as we can. Uncertainty in funding will put a brake on everything. And so it's a big problem.
Absolutely. Well, unfortunately, we're out of time. Derek, thank you so much for being with us again today. And more broadly, thanks to you and your dedicated team for your important contributions to U.S. national security. We at the Moorman Center are very honored to bring you this type of programming. Thank you for trusting us with your time and attention. This and other programming would not be possible without your continued support. Thank you to our wonderful member companies and our extraordinarily talented board of advisors. We do have one last event scheduled for 2023. That's an upcoming classified monthly circuit briefing from our friends at the National Space Intelligence Center, scheduled for December the 12th at 3 p.m., which touches on a topic that's of interest to Derek for sure, and that is how China might go about countering proliferated satellite constellations. So we'll be looking for you there. You can register for that informative top secret SCI level event on the NSSA website, which is www.nssaspace.org. On behalf of my colleagues at the Moorman Center and NSSA, I wish everyone a joyous holiday season. Thank you again, Derek. Keep up the great work, and we look forward to seeing you again soon.
Thank you, Chris.
Thank you.